Welcome back, everybody. So I don't have your exams fully graded yet. I have one last question. I have the last page to grade. So far, it's been looking pretty good, which is good news. But I will have it to you on Monday. I'll probably have the grades entered later today. And then I'll post the solutions to it also later in the day, so you can look at the answer key. I'll mention it when I hand you the exams back, but please remember that I am a person. I make mistakes all the time. Especially in parenting. But if you see something that you think is unfairly graded or you think that you deserve more points, please advocate for yourself. What's the worst thing that can happen? I say no. I'm never going to make you feel bad for asking for more points. That's what your job is. You need to learn to advocate for yourself. Worst thing that I can say is I can't give you more points back, and here's why. Best case scenario, as I say, oh yeah, I was being a little too harsh. That was right when the Seahawks fumbled the ball, so that's why I marked you down. And I correct my mistake. The other thing that can happen is easy easy arithmetic mistakes. Specifically, I'm sitting there adding up all the pages, and I get sidetracked or something. Someone asks me a question, and instead of writing a 15, I write a 10, or I write a 5. It's happened before, only once in my career, but at one point I was supposed to give a student a 15, but in my calculator, when I was entering it in, I just put the 5. The 1 didn't register. So they just got dropped 10%. And they luckily caught it. Unfortunately, it was at the very end of the semester. So they had been running on the false pretense that they were 10% down on an exam. But point being is, please look for those mistakes. I'll mention it when we get the exams back again. But point being is, please do not hesitate to advocate for yourself. Please do not hesitate to come up to me and say, why did I get this many points off, or whatever, or anything like that. Anywho, let's actually get started with the new section. So if you didn't like that section, one of the things that I love about Math 120 is that every section is segmented pretty much. There's not really much building on one topic over the other. So if you didn't like that section, we're going to be completely switching gears to a little bit of financial-based math. But in order to talk about financial-based math, we're going to talk about percentages. Probably one of the second most important things. I love unit conversions. That's the thing I would love for you guys to take away from this class. Especially if you're planning on being nurses. One of the things that you will do in chemistry a lot will be unit conversions. But the other one that's very, very useful is percentages. Case in point, the whole Chuck E. Cheese thing. I was mentioning it a little bit ago. But for the gold member pass, you get 50% off of all merchandise, right? Food included. And Costco had a deal for $100 for $75, meaning that it was 25% off. What is my total savings if I purchase a gold pass and I get those gift cards for 25% off? How much am I actually saving? Because it's not 50 plus 75%. That's not how percentages work. Actually, it's a little bit different than that. And so those are the types of things that percentages can be used for. And that's why this section is probably one of the more important ones. So to start off with, I'm going to write 12% as just as a number. So 12%. That's the percent symbol. It's a slash with 2 dots on it. And so this right here is what we call percent form. This is percent form. Now 12% written out is 12%, right? And I'm sure we all know this, but the question is, maybe you know this, maybe you don't. What does percent mean? Because it's Latin, or it's based on Latin roots. Per, remember what per means, right? If I'm trying to figure out my miles per gallon, I take my total number of miles traveled and divide it by the total number of gallons of gasoline that I used. So per means divide. So per means divide by. And then if we were on the metric system here in America, instead of our freedom system, then we might know much quicker what cent is a suffix for, or a prefix. It means 100. Like a centimeter is 100 centimeters is equal to 1 meter. So cent means 100. So 12% means 12 divided by 100. 12 out of 100. Which is 12 divided by 100, which if you write that, you get 0.12. If you do 12 divided by 100, one of the great things about dividing by 100, dividing by 1,000, any power of 10, so 10, 100, 1,000, 10,000, 1/10, 1/1000, and so on and so forth, is it just moves the decimal point. It just moves the decimal point 1 unit to the left or right, or multiple units to the left or the right. And so this version over here on the very, very right is what we call the decimal version, or decimal form. And it's important to be able to work with them in both contexts. Usually when we're trying to visualize it and trying to talk about it out loud, we use the percent form of the number. So like, because it makes more sense to us. If I say 75%, it would be way more convenient to just say 75% instead of 0.75. So that is usually we use percent form to visualize it and to talk about it. But when we're talking about the mathematics, when we're computing the mathematics, we're going to be using the decimal form. But as such, it's important to be able to convert between the two formats. So if you want to go from percent form to decimal form, what you're going to do is you divide your percent by 100 to get the decimal form. That's all you need to do is just divide by 100, because that's what percent means, per 100 of the whole. So as some examples of this, so once again, 12%, as we did above, that's 12 divided by 100, which is 0.12. 75% is 75 divided by 100, that's 0.75. We can do even weirder percents, 82.7%. That's 82.7 divided by 100, which is 0.8275. And then you can do even weirder ones. Maybe you want to do really, really small numbers. So maybe 0.1%. That's 0.1 divided by 100, which is 0.001. And last but not least, you can also, so realistically, like in the real, like you can't give more than, like, so like your coaches in Little League and whatever, they would say give 110%, which is literally impossible. Can't give more than 100% of my my energy. But if you could maybe say something like 115%, you can still write this as a decimal form. That's 115 divided by 100, which is 1.15. Point being is that you can have decimal forms of percentages that are larger than 1. And so that's how we, so as a note here, you have 12, then 0.12. You have 82.7, and you have 0.8275. So just as a little trick, the percent form, so note, percent form is always larger. Is the larger number. When you're converting between percentage and decimal, the larger number is always the percent format. And that's how you go from percent to decimal. You divide by 100. And so these are two sides of the same coin. So if you're going to go from decimal to percent, decimal form to percent form, that's going to be multiplying your decimal form, your decimal, by 100, and add the percent for the percent symbol. So it's going to be just undoing it, right? So instead of dividing by 100, you're going to multiply by 100. As an example of this, we'll just do a few. So something like 0.64, that's your decimal format of the number. Then you take 0.64 and you'd multiply it by 100, and that would get you 64%. So we multiply 100, and then we tack on the percentage symbol. If you don't see a percentage symbol, it's not in percentage form. Just as an important note. Let's look at some other examples. I mean, I could pull them out of my hat. So if you had 0.003, you take 0.003 and multiply it by 100, and you'd get 0.3%. Yes. Oh, absolutely, absolutely. Thank you. I know I'm writing pretty quick because I want to get to the fun stuff. I want to get to the actual computations. But thank you for letting me know. And one last one would be 1.33. So I bring this one specifically up because this one always throws students for a loop because they think that it's going to be because it's not like usually when we see decimal numbers, they're less than ones, like 0.5, 0.8, 0.64, 0.003. And so we're not used to seeing too many of them being larger than one. So sometimes we think that that's a percent form, but if it doesn't have the percent symbol, it's not in percent form. So you treat it like decimal form. So 1.33, what you do is you'd multiply that by 100. So 1.33 multiplied by 100, and you should get 133%. But that seems like that's a lot of work to write down. I mean, not a lot of work, but it's more work than you need to show. Because there's a shortcut. If you've noticed something that's always happened, multiply by 100. 100 is 10 to the second power. And you'll notice that every single time, regardless of whether I'm going from percent to decimal, I move the decimal 2 spaces. So when I'm going from percent to decimal, I've moved it 2 spots to the left. 1, 2, and it's over there. So starting here, move 2 over, 0.827. Oops, I wrote 0.827. So I should get rid of that 5. I think I was supposed to write 82.7. I wrote. Oopsies. And then vice versa, being given 0.64 to go from decimal form to percentage form, I just move the decimal place 2 points to the right, and I get 64%. So that's the shortcut. So percent form is on one side. And I don't know if you've ever seen one of these types of symbols, but I'm going to draw it for you. So it's a 2-sided arrow, but only one side is pointing one way and one side is pointing the other way. So if you want to go from percent form to decimal form, you're going to follow the red line. And the red line says to move decimal point left 2 digits. So if you want to go from decimal form, from percent form to decimal form, you're going to move the decimal point 2 digits to the left, making it a smaller number. And if you want to go from decimal form to percent form, you're going to follow the blue arrow going backwards, and you're going to move the decimal right 2 digits, thereby making it a larger number, because you're moving the decimal point to the right, and that will make it a larger number, as you'll see when we look at these 2 examples. So I hope everyone can see how that double arrow works. So if you want to go to the right, you're going to follow the red line. That means you're going to go from percent to decimal, and you're going to move the decimal point 2 units to the left. If you want to go from decimal to percent, you're going to go to the left. You're going to follow the blue line, and you're going to move the decimal point to the right too. And once again, the reason why that's happening is because you're multiplying or you're dividing by 100, which is 10 squared. Whenever you multiply by 100 or any power of 10, it just moves the decimal. It moves the digit, the decimal point 1 unit to the left or the right. So, as an example of this, let's say you're given 64%. We think of that as 64.0. And so we'd move it 2 units to the left to there to get our answer of 0.64. The faster you get at this, by the way, you don't need to write this down. In fact, if you already know how to do this, perfect. And you're golden. But this is what I'm doing in my head typically. I'll write it down for us as we go along, but as we continue, maybe after a sizable amount of time, I'll switch to it. And just immediately computing it. And so on the flip side, maybe I have 1.835. No percent symbol, so this is the decimal form of the number. And so what I'll do is I'll just move the digit to the right, 2 digits to right there to get my percent form, which will be 183.5%. So any questions on how to convert between decimal and percentage form? Nothing too terrible yet, but how do we utilize them? How do we utilize percentages? So that talks about the percent equation. This is the formula you will use for any percentage problem, even if you don't realize it. So what it says is that an amount, let's call it lowercase a, is some percentage, let's call P, of a base, which we'll call quote unquote B. So we have the amount, the percentage, and the base. So one of the things that's very, very useful in math when you're learning mathematics is being able to take an English statement, taking a literary statement and converting it to mathematics. One of the key things to remember is that is or are means equals. So the amount A is, so A equals a percentage P of a base B. So the of meaning that it's a multiplication. So as an example of reading this, 10 is 50% of 20. True statement. If I take 50% of 20, I get 10. Half of 20 is 10. So here, your A is equal to 10. Your P is equal to 0.50. Now I'll explain this in just a second. And then of 20 tells you that B is equal to 20. So the quick-handed way is A is P% of B. And to write that as a mathematical equation, you have A is equal to P times B. That is the formula for percents. Boom. A is equal to P times B. And that's the formula we'll be basically using for the entirety of this lesson on 2.2. So note, where do I write the note? Do I want to write it right below it? Yeah. So important. So notes. The first note. Should write it down. Again, I realize I do write fast. Right. The first thing is that with the percentage equation, you will get the answer, you will always get the answer wrong if you do not convert your P to decimal form. Whenever we're working with math, whenever we're doing the mathematics with percentages, always keep it in decimal form. So make sure your p-value is in decimal form when working with the formula. And then the second note is that, and this is something for your answers. If you're solving for P, if solving for P, you need to convert to percentage form at the end. For your final answer. In essence, when working with any formula that involves, when working with any percentage, if you're doing mathematics with it, keep it in decimal form. But if you're being asked to find the percentage, you want to write your actual answer in percent form. So, and that's just kind of a generally accepted rule of our society, is that if I'm talking about a percentage, I want to say it as a percent form. I don't write that 20% of students like 0.2%, 0.2 students like that. I say 20% of students like my class or whatever. Yes.
At the top where it says an amount A is something, what does that say?
Is some percentage. That's a pretty bad sum. This is just that's just a squiggle. That's terrible. I should be ashamed. Thank you for shaming me. I appreciate the shame. Okay. So the standard question that you get asked at first is just being able to convert. Then we'll actually start talking. Once we do some practice with the basic mathematics, quote unquote, like the groundwork, then we'll actually apply it to real life situations. So, example. What is 25% of 70? Now, how do I identify? So this is a percentage problem. So I need to identify. So since it's a percentage problem, I'm using A is equal to P times B. But what is A equal to? What is P equal to? And what is B equal to? It can be hard at first. Well, as you get more and more practice with it, you get better at it. The thing that I like, two things. The percent is almost very, very quick to find because it's the only one that has a percent symbol. So 0.25, because I'm going to convert this to decimal form, moving it. Oh, let me. Whoop, whoop, there. And that's why it's 0.25 as a decimal. Now the question is, which one is A like which is the unknown and which is the base. So like I just gave it away. Which one's the amount and which one's the base? Is the amount the unknown or is the base the unknown? And the giveaway is this of this right here. Of is a giveaway for the base. So B is 70. If you ever see of blank, that means, like I'd say probably 999 times out of 1,000, that will be your base. So if it says of blank, blank is your base. So A is the unknown number. So we've got everything we need. We've got the formula. So all we need to do is solve for A. And luckily for us, A is already on one side. So there's not really much calculation, not much algebra to do. It's just arithmetic. So A is equal to 0.25 times 70, which is equal to 17.5. So 17.5 is 25% of 70. Now, some of these ones you might be able, like, the way I might have done this without using a calculator is thinking about it in terms of 10%. So you've got two 10% and one 5%. 10% of 70 is 7. So you've got two 7s, that's 14. And then half of 10%, 3.5. So 14 plus 3.5 is 17.5. That's the way mine works, but yours might work differently. And that's just if I want to compute it without using a calculator. We'll talk about that in a second. Example 35 is 22.2% of what number? Do you need to write down A equals P equals B equals before writing down the formula? No, you don't have to. But if you're struggling with this at first, it always helps to write them down. You'd be surprised at how well jotting down your thoughts can help organize your work. Even if it's wrong, you can always erase it. That's why all pencils come with an eraser, because we all make mistakes, right? So it's okay to mess up. So I'm still going to identify it. A equals, P equals, and B equals. So percent, always quick to find because it's the only thing that has a percent symbol. So I should write 0.222. Make sure you understand where that came from. From the 22.2%, we're going to convert it to decimal form. Yes?
But it already has a decimal.
So, excellent point. So that's the tricky part of this. A percent can still have a decimal in it. And a decimal could have no decimal. Yeah, like, so for example, I could tell you 2, and that means 200% because there's an implied 0.0. And so we move it 2 units to the right and get 200%. So a decimal number or a percent number can't have a decimal point, but it's not in decimal form. Excellent question. And that's one of those frustrating things in mathematics. As you continue on, you get more and more upset with how mathematics is written. There's a general frustration thing. Sorry to go off on a side note, but one of the biggest frustrations that a lot, like my brother, so I've come to accept it as a mathematician. It's just part of my daily life. And so I just have to accept the madness of it. But my brother, who's a mechanical engineer, he got really, really frustrated because of there's no set notation in mathematics. There's no set guidelines. When you get up into higher division mathematics, the absolute value symbol can mean about 10 different things depending on the context. In vector calculus, it tells you the magnitude of a vector. In regular language, it's the absolute value. In abstract algebra, it's the cardinal, or in real analysis, it's the cardinality of a set. In abstract algebra, it's the rank of a group or something like that. I can't remember exactly. I didn't like abstract algebra very much. But point being is very, very frustrating mathematics that we have all these different symbols that mean the exact same thing. One of the most frustrating things if you decide to take Math 126 is you talk about coordinate points, but that symbol also means an interval. So there's a lot of frustration. But point being is a percent can have a decimal. So that's 22. Since it has the percent symbol, that's the percent form. So we convert it to a decimal by moving it 2 units to the left to make it a smaller number, make it the smaller version of the number. So then the fact that it says of what number means that the unknown is the base. The base is unknown. And so by process of elimination, the A must be 35. So setting up the formula, A is equal to P times B. So 35 is equal to 0.222 times B. And this is just a linear equation. We've been working with these ones. You've got B and it's being multiplied by 0.222. And since we want to solve for B, we need to undo that process. So we're going to divide by 0.222. 0.222 divide on both sides. And here's a fun little question. Is the number going to be bigger or smaller? It's going to be bigger. When you divide, like the smaller the denominator, the larger the number. The bigger the denominator, the smaller the number. And case in point, did I talk about A and W here? Did I talk about A and W in this class? Okay. So this is why we need to know this. This is an important fact. Smaller the number in the denominator, the bigger the overall number. And so the point being is that A and W tried, like, they don't just make root beer. They actually have some fast food chains. I don't know if you've ever been to one. They're pretty good. But they were trying to compete with McDonald's once McDonald's enters with the quarter pounder, right? 1/4 a pound of beef. That's what a quarter pounder is. And they said, well, we got a new burger. I forget what it's called, but it's got 1/3 a pound of beef, which is way better. But Americans thought that 1/3 was less than 1/4 because 3 is a smaller number. But since we know that a smaller denominator means a bigger number, like 1/3 is 0.3, whereas 1/4 is 0.25. And so, but Americans were like, well, that's a smaller burger. I don't want that. And so it didn't work out. Yay, our education system. Failing us right there. Smaller denominator means bigger number. Bigger denominator means a smaller number because smaller, it's a larger whole. Anywho, doing this, let's use a calculator because I don't know what 0.22 is off the top of my head. 35 divided by 0.222 is 150. So B is going to equal 157.657657 repeated. I guess I should just write 657 repeated. That. So let's just approximate to two decimal places, roughly 157.66. So 35 is 22.2% of 157.66. We'll do 2 more of these examples just to bring it home, and then we'll move on to some actual real life examples. Example is to say 217.1 is what percent of 2,700? Okay, so that would be A, P, and B. What is A? So take a second, think about it. Try and find out which one's the unknown, which one's the amount, and which one's the base. A is going to be A is 217.1. Because the of 2,700 is telling you that the 2,700 is the base. The fact that it says of means that B is 2,700. And then percent is the thing that is missing. It says what percent. So the percent is unknown. So A is equal to P times B. Do I need to write that formula every single time? No, you don't need to write it unless you're trying to practice memorization. If you just want to fill in the chart or like fill in the formula, that's fine with me. Well, that's 217.1 is equal to P times 2,700. And we're trying to solve for P, so we're going to divide both sides by 2,700 to undo the multiplication. Divide by 2,700. And that'll cancel it on the right and give us that P is equal to, so 217.1 divided by 2,700 gives me 0.0804074 ... on and on forever. And John Doe's student, silly John Doe, always getting things wrong, even writing a bad rectangle that's slanted for his answer. Silly John Doe. He makes this his answer. Why is John Doe wrong? Exactly right. You did not multiply it by 100% or 100 to convert it to percent form. Now, if this ever happens to you on a quiz, so if this was on an exam and you wrote that as your answer, don't fret. That's not a 0. That's probably, if it's a 10-point problem, that's probably an 8 or a 9 out of 10. It's one last step that you forgot to do. However, on Canvas, on your quizzes and your homeworks, it might mark you, it will mark you wrong and you'll get 0 out of that points. If that ever happens, please let me know. Just email me saying, hey, I forgot to convert to percent form, and I will give you most of the credit back. So if it's a 1-point problem, I'll probably give you 0.8 back. So not a big deal if you make that mistake. Just try to learn from that and move forward. So what we're going to do is we're going to move the decimal 2 spots to the right to make it a larger number, because percent form is always the larger number. But you can also multiply by 100. You can do that in your calculator. And that gets you 8.0407 for on forever. So 8.04% if we're going to round to 2 decimal places. And that is why I like you to write down as many decimal numbers as you can, as long of a decimal expansion as you can, and then simplify, then round. Like round at the very, very end. This is going to be important, especially when we move on to finance math specifically, in particular, compound interest. If you round early, your answer will be drastically different. And so the more decimal places you write, the more accurate your answer is. If you didn't write down extra decimals, you might just write 0.08, and then you're going to be off by 0.04%, which is not a big deal in the grand scheme of things, right? Saying, I mean, like, I guess it depends on what you're talking about. 8.8% versus 8.04% when you're talking about the population of the world, that's a substantial difference. Otherwise, like on an exam, 8.04% off versus 8% off is not a big deal, but depends on the situation. So point being is please write down as many decimals and then round at the very, very, very end. Last one, and then we'll move on to some real life examples. So 210 is 16% of what number? I'd like you guys to slowly solve this one yourselves. I'll slowly fill in details. The way I usually do this is if you are stumped on what to do next, look at the screen to see which thing you need to do next, and then try and continue it yourself. You should get that B is equal to 1,312.5. And I wonder why that is such a nice number. It didn't have a random super long decimal expansion. It has to do with the fact that 16 is a power of 2. 16 is 2 to the 4th. 2, 4, 16, yeah. 2 to the 4th. Whenever you divide by a number that's either a power of 2 or a power of 5 or a combination of those two things, you always have a finite decimal, which is pretty cool, pretty nifty. And those are the only numbers that do that. If you start dividing by a 7, like any other number that's not a 2 or a 5, or a product of 2s and 5s, you won't be able to get a finite decimal number. Very fun stuff. Fun. I'm abusing language right there. I don't think it's actually fun. Depends on your definition, right? So let's actually look at an example. A student correctly answers 27 out of 40 questions on the test. What percent is this? Now, granted, this is assuming that every single question on the exam is worth the same amount of points, which is not the case with my exam. As you saw, like some questions are worth 10, some questions are worth 5, some worth 6 and whatever. But that is we're assuming that each question is worth the same amount of points. Now, yes, we're working in the percentage section of our material, so of course this is going to be a percent problem. But the fact that it says what percent is this is the dead giveaway that this is a percent problem. So here, A, P, and B. We're trying to find the percent, so that's the unknown. And then it says out of 40. The fact that it says out of 40 tells you that B is equal to 40. The base here is 40. And by the way, if you know the answer should be 27 divided by 40, please go ahead and do so. That's what you're going to see that's exactly what happens. But as an aside, so 27. So A is equal to P times B. I'm going to stop writing it after this one, by the way, and just write down write down the answer. So you get 27 equals P times 40. And so to undo the multiplication by 40 to solve for P, we're going to divide by 40. Hence why when you're trying to calculate your percentage, you take your score and divide it by the total number of points. So you get that P is equal to 27 divided by 40 is 0.675, which you're going to convert to percent form. So it should be 67.5%. So a D plus. Come on, give me a box. That is totally a box. What are you doing? What do you mean? There we go. Thank you. Okay. Let's skip that example and go to an actual situation. So, example, now granted, most clothing stores do this for you, but a clothing store has a sale for 17% off of the whole store. I don't know. It's the 17th day of the month. They just want to do a 17% sale. I don't know. Don't question it. You want to buy a jacket that retails for $68.99. How much will you pay if you only pay sales tax which in Nevada, I don't know. What's the sales tax in Nevada? Ooh, gone down. 6.85. Last time I wrote it, it was 8.38. Did I say 6.25? Nevada sales tax. I want to ask you the same question. So let's just say 6.25%. If you only pay a sales tax on the sale price. Okay, there are two ways to do this. There's a long way and then there's a quick way. And I'd like you to know both of them because there's the long, like we'll start off with the long way, which is the brute force method. So solution. For like, in order to calculate sales tax on the sale price, we need to know what the sales price is. Because the original price is $68.99. But that's not what we're going to be paying sales tax on. We're going to be paying sales tax on the sale. So first, find sale price. The question is, which is A, what is P, and what is B? P is always the dead giveaway. 17% off, so P is 0.17. And the question is, are we trying to find A? Like, is A the unknown or is B the unknown? A is the unknown. It says 17% off of the whole store. So 17% of 68.99. Because of the whole store. Since it's so of the whole store, so in particular, 17% off of 68.99%. So A is the unknown. So that's going to mean that A is equal to P times B. So A is equal to 0.17 times 68.99. And 68.99 times 0.17 is 11.7283, which we're to round to the second decimal place because that's what makes sense. Get it? That's the second decimal, so that's cents right there. That's hilarious. So approximately $11.73. Now, if you're looking at that and you're saying, wow, that's a really good deal on the shirt, on the coat, you're wrong. That's not the actual price of the coat. That's the amount off of the price. We are trying to find 17% of $68.99. So we're trying to find the amount that comes off. So at the end of the day, then, that would mean that the sale price equals $68.99 minus that $11.73, which gives us 57.26. Oh, no, that's not our answer, though. Now we need to pay sales tax. So we got to do this whole thing over again. And I'm going to show you there's a much quicker way to do this, by the way. So we're going to pay 6.25% of the sale price. So 6.25% sales tax of 57.26 implies that A is the unknown, P is 0.0625, and B is 57.26. So now we need to calculate, so just as a reminder, so what we first did is we needed to find the sale price. What we did is we found the percentage off. The dollar amount that's off based on the percentage off. And then now that we have the sale price, now we need to calculate tax. Granted, of course, we live in a day and age where this is kind of a moot point, right? You don't need to actually figure this out. We just pay for it up front. But either way, maybe you're without a calculator, maybe the store's system is down. Does everyone remember, did anybody get disrupted by I forget what was the name of it? It happened recently that error in the coding on Microsoft computers. I forget what it's called. It was something gate, secure gate or something like that. They messed up in their code and it threw everything off because once you installed it, it had to be fixed manually. So all the flights got screwed up. I actually had to drive I had a flight planned in Vegas and I had to drive all the way to Phoenix to get a new flight. So just drove there straight from the airport. Great old time. But anyways, I don't know why I got on that sidetrack. Doesn't matter. It's your guys' fault, not mine. A is equal to P, which is 0.0625 times 57.26, which is 625 times 57.26, which is going to be approximately $3.58. It's 0.578, and Uncle Sam's definitely going to want that extra change from you. That extra half of a cent makes a big difference when you're talking about over 1 billion people. So that's in tax. $3.58 in tax. So the total cost to you is going to be $57.26 plus $3.58 in tax, which is a whopping total of, so 57.26 plus 3.58, $60.84. That was a doozy. That was a 3-step, that was actually like, so 1, 2, 3, 4, 1, 2, 3, 4, 4-step process instead of something that could be a lot quicker. So here's an alternative method that would be faster to do. Unless there's any questions on that. And that method is completely valid. If this was a problem on the exam and you did it this way, that's 100%. It's a gold star. Got it perfectly correct. Here's an alternative way. If the item is 17% off, that means it is 83% of its original price. Where did I get the 0.83 or the 83%? The original price of the item is 100% of it. And if I take 17% off, then 100 minus 17, that's 83. 100% minus 17% equals 83%. So what I can do instead, I don't necessarily need to find the amount off. I can just find out what 83% of the original price is. So here, A is going to be the unknown, P is going to be 0.83, and B is going to equal that price of that sweater, which was, or that coat, which was $68.99. So A will equal 0.83 times 68.99. And you get 57.26 when you round. 57.26, 57.26. We got the exact same answer, which is what you'd expect. So if the item is 17% off, that means that it's 83% of what its original price is. Now with sales tax, adding on sales tax of 6.25% means we'll pay 100%, 106.25% of the total sale price. So this is another way. You don't have to figure out what the sales tax is first. You can do that all at the same time. If it's going to be 6.25% in sales tax, that means if you take the amount of money, the 100% of the money that you're going to be paying for the price or for the item, and add on that 6.25%, that'll give you the price of the item with sales tax included. Does that make sense? No, it doesn't. So let me thank you for shaking your head. I appreciate it. I really appreciate that. So let's maybe look at it without looking at sales price for just a moment. Let's say the item is not on sale, $68.99. If sales tax is 5%, I'm going to be paying 100% of the item plus with sales tax at 6.25%. So if there was no price off, if there was no sale price, I'm paying the full price of that item, which is 100% of that item, plus an additional 6.25%. So that's why it's 100 plus 6.25%. Now, the tricky part with this problem is that I'm only paying sales tax on the sale price. So that's kind of the weird situation. But that's what it is in general, is I'm taking the total amount that I'm going to be paying, 100%, and I'm adding on an additional 6.25% of that. So that's why when you're doing sales tax, you just make it out of 100 and 6.25%. So A is equal to the unknown, P is equal to 1.0625. And B is equal to 57.26. So A is going to equal 1.0625. Multiply that by 57.26. And you get 6083.8, which rounds up to 60.84. $60.84. So you can do it in a two-step process versus a one-step process. Not wrong either way. It's just this is a quicker way to do so. The only question then, this is situational. If it's asking for how much is off, then you'd want to do the first method because that's telling you exactly how much was taken off. But if you're looking for the actual price, the sale price, then you'd want to be doing it this way. So it's It's situational, but this is faster. Important understanding how the percentages work. It's what I'm trying to go for here. Any questions on that? Nothing? Okay. Then, now this is also dated back in the day, back in my day, we didn't have calculators that could figure out tips for you. And we didn't have little buttons to press on the credit card application things that would tell you exactly how much 10% is. So back in my day, that didn't happen. We had to figure it out by hand. And so here's Phil's hot tip. If you're trying to figure out how much you should give, I bring this one up because I remember when I was a kid, I went to PF Chang's with my friends. I'm not paid by them. It's just this where this happened. And I remember there was a couple who was sitting right next to us, and they got into a huge argument because the girlfriend or the wife, I don't know which. Either way, I hope they're divorced at this point. Didn't want to calculate tip, and her husband or boyfriend was like, "What's 10% of 90?" And like this whole story, like screaming at her, like trying to make her do the tip math, and she didn't want to do it because, of course, if you're being yelled at, you don't want to do this a certain thing for the person. I'm talking at you, son. Stop yelling. Of course, I don't want to do what you're going to do if you're just going to yell at me. Just gives people a bad vibe. So, but anyways, I wanted to go up to that girl and hug her. He was doing it all wrong. Here's how you do tip very quickly without having to look at your calculator or bust any of that stuff out. So, Phil's hot tip for 20%, for approximately 20%. Step one, move the decimal point 1 digit to the left to get 10%. So for example, let's say you're doing all you can eat sushi with your spouse or your significant other, and the price comes out to $74.89. Make sure you got a bottle of sake or whatever you can drink, if you can. And so you're just going to move the decimal place 1 unit to the left and get $7.48. So this is 10%. So 20% would be doubling this number, but who wants to double 7.489? I don't want to do that in my head. I had to bust out that, so 7.489 times 2. I don't want to bust that out. I don't want to do that. I don't have paper in front of me when I'm eating sushi. My table's all covered in soy sauce. I don't want to do that because I'm a sloppy eater. Not actually, but anyways, let's say I was. Step 2, if you had good service, round to the nearest dollar. Round up to nearest dollar. And bad service, but in this day and age, because they screw all your workers over, there's all those rules. I don't know if you know this, but like the actual price, the actual base pay for restaurant for waiters and waitresses and stuff is actually really, really low. It's below the minimum wage because there's stupid loopholes in the system. So maybe we just always give good service, always round up. It's hard enough being a person in the service industry. A bad service though would be round down. So like maybe if the person spits in your food, then round down. Person spit in your food, then round down. And then 3 is to double that number for roughly 20% tip. This is a complete moot point in Europe because they don't do tips or whatever. It's a weird thing apparently. It's just America thing, but either way. So as an example of this, so now you can bust this out and you can help that girl who's getting screened out by her boyfriend or husband and tell them that they should leave that person right away. Let's say the cost was $57.22. So you'd write, so 10% of that would be $5.72 and 2/10 of a penny. So good service or bad service. Good service, you round up to $6, and bad service, you round down to $5. So times 2, $12 tip, times 2, not percentage. What am I doing? What am I doing? Tripping out. $10 tip. And then just add that to your total and you're boom, you're done. That way you don't have like, and so the nice thing about this method is then you don't have to do any addition or subtraction of the cents, because now you're just working with a solid $6.00 or $10 or $12.00. Much faster to do. You don't have to worry about carrying over the digits or whatever. And it just gives you a rough estimate, which in actuality, so 12 divided by 57, a $12 tip is actually a 21% tip, and a $10 tip is 7.22 is a 17.5% tip. So it's roughly around 20%. It just, you're like almost always, if you do this this technique, you're going to get roughly above 15%, which is I assume, at least the way I was taught, was around the rough choice that you should do is at least 15%. But either way, that's my hot tip. But once again, this is a complete moot point because now literally my phone can, or my watch can do it for me. So it's a big bummer because this was a really good tip back in the day. And I just like telling that story because it's ridiculous to me that you would want to berate your significant other just because they didn't want to do a little bit of math. Yes. No one regret it to this day. That's why I tell that story, is to shame myself to make sure that if it ever happens again, I will know better. Excuse me, sir. You need to teach her this quick tip. Anyways, anything else? We don't have enough time for anything else. That'll do it for today. Oh, yes. So, yes, that would be the, so excellent question. Is if you're dealing with sales tax, does it go on just the price of the item overall, or does it go on just the sales tax? The intuition would be that it should only be on the sale price, because you shouldn't be paying tax on something that you're not paying. So that is the convention, is that you're only paying sales tax on the price that you're paying, i.e. the sale price. But I will make sure on an exam that I'm very particular. I will say exactly what I said above, where I said, assume that you're like, I'll write in in italics, I'll say, assume you're only paying sales tax on the sale price. So I will make sure it's very clear on my exam. That being said, you can always ask questions. And if you get it wrong because you didn't make that assumption on the exam, on a homework or a quiz, please let me know and I will give you full credit back. Okay? All right, guys, have a great rest of your day, a great weekend. And if you have any questions, feel free to email me. Otherwise, I will see you guys on Monday.